Hello everybody, welcome back to Channel ANZ Machinery Incredible Giant Crankshaft Forging Process. The forging of a heavy-duty engine crankshaft is a fascinating display of engineering precision and sheer mechanical power. It begins with forge rolling operations, where high-strength steel billets are heated to extreme temperatures and shaped into rough crankshaft forms using massive rolling machines. This initial shaping lays the foundation for a robust and precise crankshaft. Next, the workpiece undergoes forging on a 12,800-ton screw press, a behemoth machine capable of applying immense force to refine the crankshaft's dimensions and enhance its strength. The press molds the steel with incredible precision, ensuring the structure can endure the high stresses of engine operation. After forging, the crankshaft is trimmed and calibrated using a 2,500-ton hydraulic trimming press. This operation removes excess material and ensures the piece conforms to exact specifications. The precision in this step is crucial to achieving a perfectly balanced crankshaft. The forging process continues with a controlled cooling operation, where the crankshaft is cooled at a carefully regulated rate. This step enhances its mechanical properties, ensuring durability and resistance to wear over time. The crankshaft then undergoes automated warm straightening, a high-tech procedure that corrects any deformations from the earlier processes. Advanced machinery heats and straightens the crankshaft with extraordinary accuracy, guaranteeing it is perfectly aligned. The CNC system employs advanced programming to execute intricate milling, turning, and drilling operations with micron-level precision. Multiple axes of control ensure that every journal, web, and counterweight is shaped to exact specifications. Machining a 12-meter-long crankshaft on a CNC machine is a highly specialized process requiring precision, expertise, and advanced technology. The DB12500, a state-of-the-art CNC machine, is specifically designed to handle massive crankshafts for marine engines, power plants, and other heavy-duty industrial applications. High-speed cutters and robust tool materials like carbide are utilized to handle the tough alloys typically used in crankshaft manufacturing. Coolants are continuously applied to manage heat and prevent thermal deformation. Once the machining phase is complete, the crankshaft undergoes a meticulous grinding process to achieve a smooth surface finish and precise dimensions. The DB12500 employs specialized grinding wheels and high-resolution sensors to maintain tolerances within a few microns. Critical areas, such as journals and fillets, receive particular attention to ensure optimal performance under heavy loads. Every stage is monitored through advanced measurement systems. Non-destructive testing methods, such as ultrasonic and magnetic particle inspection, are applied to detect internal flaws and ensure structural integrity. The DB12500's ability to handle complex machining and grinding of a 12-meter crankshaft reflects cutting-edge engineering, setting new standards in manufacturing excellence for large-scale components. CNC crankshaft machining and grinding process for long crankshafts. The precision machining of long crankshafts is a cornerstone of modern engine manufacturing, requiring advanced equipment and techniques to achieve exacting tolerances. One standout solution for complete crankshaft machining is the VDF 450-4 TCM horizontal turn mill center by VDF Bohringer, renowned for its efficiency, accuracy, and versatility in handling complex operations. This high-performance machine integrates turning, milling, and drilling operations into a single setup, significantly reducing production time and ensuring unparalleled precision. Its robust design and state-of-the-art control systems enable it to handle the unique challenges of machining long crankshafts, including maintaining stability over extended workpiece lengths and managing intricate geometries such as counterweights, main journals, and oil passageways. The machining process begins with rough turning to remove excess material, shaping the crankshaft to its general profile. Following this, advanced milling tools carve out features like keyways and counterweights with pinpoint accuracy. The VDF 450-4 TCM's integrated tool changer minimizes downtime, enabling seamless transitions between operations. Once the primary machining steps are completed, grinding becomes essential to achieve the smooth surface finish and tight tolerances required for optimal performance. Precision grinding ensures journal roundness and surface quality, which are critical for minimizing friction and wear in engine applications. The machine's stability and vibration dampening capabilities are vital during this stage, particularly for long crankshafts, where even minor deviations can lead to significant performance issues. The VDF 450-4 TCM is particularly suited for handling the complexities of long crankshafts, thanks to its exceptional rigidity, dynamic tool control, and ability to execute multiple processes in one clamping. This all-in-one capability streamlines production while maintaining consistency and precision, making it an invaluable tool for industries requiring high-performance crankshaft manufacturing. ALFING Kessler GmbH BAS2 two-station machining center. The crankshaft is included in the new machine type with a closed workspace that is CNC integrated in a machining center. The ALFING Kessler GmbH BAZ2 two-station machining center is a cutting-edge solution designed for precision manufacturing. This advanced machine type features a fully enclosed workspace, ensuring enhanced safety, reduced contamination, and optimal working conditions. The integrated CNC system allows for seamless control and precise execution of complex machining tasks, catering to the high standards required in modern production environments. A standout feature of the BAS2 is its specialized capability to handle crankshaft machining with unmatched accuracy. By incorporating this key component directly into the design, the system is tailored to deliver superior performance in automotive and industrial applications. The two-station configuration enhances efficiency by enabling parallel operations, reducing cycle times and boosting productivity.